in this video, we're going to cover the different types of switches that we could find in the market. The first switch that we're going to talk about is the push-to-make switch. To show you how this switch works, I connected it to a circuit with a resistor and an LED. To power up this circuit, I'm going to be using a 9-volt battery. Now this switch is a normally open switch, which means it's normally off. Whenever the button is pressed, the switch turns on. It allows an electrical current to pass through. Whenever the button is released, the switch will return to its normally off state. Now let's talk about the push-to-break switch. This switch is the complete opposite as the one we've seen before, because this switch is a normally closed switch, which means it's normally on. When the button is pressed, the circuit is broken. Therefore, it switches off. However, when you release the button, the switch will return into its normally closed state. Next, we have the toggle switch. And the toggle switch switches on depending on the position of its top lever. Then we have the slide switch. And this switch switches on depending on the position of its slider. If you move the slider towards the contacts, the switch switches on. If you move the slider away from the contacts, the switch switches off. Now let's talk about the rocker switch. This on or off switch contains a rocking back and forth function just like a seesaw, and it switches on depending on which position it is in. Next, we have the tactile switch. This switch functions just like the push-to-make switch. However, this switch makes a clicking sound whenever it is pressed. This clicking sound alerts the user that the switch is being switched on. Next, we have the tilt switch. And again, this switch is connected to the same circuit with the resistor and LED. A tilt switch will turn on depending on the position it is in. Like for example, if you tilt it, it will switch off. If you tilt it back again into the original position, it will switch on. This is possible due to a ball of mercury or metal ball inside the tilt switch. When the ball touches the contacts of the switch turns on. When not, the switch turns off. Lastly, we have the reed switch. This switch allows an electric current to pass through it whenever a magnetic field is near. This function is possible due to two ferromagnetic blades inside the switch. These two blades come into contact with each other whenever a magnet is near.